அட்டெண்ட் பண்ணாங்களா? you're online, are you able to hear me?
Yes, sir.
Okay. Okay. Shall we get started? So listen. See, I think we have completed till permutation and combination, which is the 6th chapter, right? The 7th chapter is binomial theorem. But what I thought is binomial theorem is also dry. We had been discussing all dry topics like linear inequalities, all simple, but a lot of theory involved in it. So this chapter will actually have a lot of logical and good problems in it. I thought we'll start with this. Then I'll go to the binomial theorem part. Okay. So this. No. So the chapter that we are going to start is going to be the 8th chapter, which is the sequences and series. Okay. It is going to be the sequences and series. So here we need to understand what is the difference between a sequence and a series. Okay, let's first see the introduction of this chapter. So first, let's try to understand these two terms of what is a sequence and what is a series. Okay. See, if I give you a set of numbers, right? If I give you a set of numbers where there is a specific pattern that you can define between the numbers. For example, the simplest example we can think of is 1, 2, 3, so on till infinity. Okay, so on, it keeps on going. Is there a pattern that is existing between these numbers? I'm not asking what set does these numbers fall into. I'm only asking, is there a pattern you're able to see in them? What is it? It starts with 1, the next number is 2. So there is a common difference of 1 existing between each number. Suppose I think of numbers like this, 2, 4, 6, so on, something like this. There is a pattern, right? I can think of numbers like this, 1, 2, 4, 8, so on like this. Is there a pattern? So what is it? This is 2 power 0, this 2 power 1, this 2 power 2, 2 power 3. It keeps on going like this. The sequence keeps on going like this. So if at all you have this kind of a pattern where the numbers are separated by a comma, then you call that to be a sequence. Whereas if you perform the operation of, I think there is a traffic jam. Let me check in. See, nobody is there, but okay. But honest being blown. I don't know why. Nobody is there in the vehicle. I thought somebody slept on the horn. I asked. One guy came there from there in a cycle. He was checking all. He was going and trying to switch off every horn. Nothing worked. I see a team member has gone down. I don't know what is this. It's continuously honking. I think something got stuck or some sensor is lost. Not sure. Okay, we'll see. Yeah. So this is all about sequence. So when you talk about the numbers which have a pattern separated by a comma, it's called as a sequence. But if the same numbers are performed, if there is an operation of addition that is performed between the numbers following the sequence, you call that as series. In the sense, you have 1, 2, 3, so on till infinity. If you make it as 1 plus 2 plus 3 plus so on, then you call this as series. So basically, it's the same set of numbers, but if you just differentiate and write it as a set, you call it as a sequence. If you perform an operation of addition, you call it as a series. That is not any number, they should have that pattern. No, only addition. Only addition. So you should only perform the operation of addition between those numbers. Okay, for example, here, this is 2 plus 4 plus 6 plus so on till infinity. So what can you say this as? This is a series of even numbers. This is a series of natural numbers, right? This is a sequence of natural numbers. This is a sequence of even numbers. So I hope you're able to understand that language, right? So having said this, basically when you talk about a sequence, since it is going to be a pattern that is being followed, sequences are classified into different types of progressions. So we can think of different progressions, which we call it as sequence, of which one of them is called as arithmetic progression, and the other is called as GP, which is called as geometric progression. And the third type is HP, which you call it as harmonic progression. Harmonic progression. Okay, what are they? Arithmetic progression, which you have already learned in your 10th grade. Geometric progression, about which we are going to learn this year. Harmonic progression is not there in your syllabus, but if it is better, just for an idea, I gave this concept. Okay. I hope I'm clear with what is the introduction of this chapter, right? Just make a quick note of it. Done. Okay. So we'll discuss about the first type of progression. We'll discuss about the first type of progression, which is the arithmetic progression, right? Suppose we have the numbers which follow the sequence like this: 1, 5, 9, 13, so on. What is that you're able to observe in this? Between every two subsequent numbers, there is a common difference of 4. So how will you say how will you report it? Will you say it is +4 or -4? It will be plus 4, because you always subtract it from the subsequent number and the preceding number. For example, you do the operation of 5 minus 1, 9 minus 5, 13 minus 9, like that. Okay. So listen to this language. The difference between 1 and 5 is 4 only. So the difference between 1 and 5 is also 4. The difference between 5 and 1 is also 4. But when I ask you what is 1 minus 5, it will be minus 4, whereas 5 minus 1 will be plus 4. So when you talk about this common difference, right, the term which we are going to discuss, you need to be very particular about the sign. So if at all the sign is positive, then you're trying to say that the subsequent number is greater than the preceding number. If the sign is negative, then the subsequent number should be lesser than the preceding number. So that's why it's very important. Okay. So having said this, if at all I have the numbers as A1, A2, A3, so on till AN, right? If I have this kind of a sequence, then the difference between the second term and the first term is supposed to be equal to the difference between the third term and the second term is supposed to be equal to 4 minus 3, and this process continues till we find the difference between an minus 1. And this difference is what we call it as small d, which is given a name called as common difference. So it's called as common difference. So having said this, if I take A1 as A, then from this set, can I say A2 minus A1 is equal to D? A2 minus A1 is equal to D, which implies A2 minus, what is the value of A1? It is A. So A2 minus A is equal to D, which implies A2 is equal to A plus D. Makes sense? A2 is equal to A plus D. So when is this possible? When you consider the first number to be A and the common difference to be D. Similarly, if I take this set and equate it to D, that is, if I write A3 minus A2 is equal to D, then what does this imply? A3 is equal to A2 plus D, but what is A2? A2 that I already know is A plus D. So A plus D plus D, it is going to be A plus 2D. Right. Now, I write A4 minus A3. Okay, I'll directly go to the last term. Okay. So if I follow this process and I directly go to the last term, that is an minus 1 is equal to D. Now tell me what will happen. This will be equal to, this implies an will be equal to an minus 1 plus D. Right. Now you are supposed to tell me if the first term is A, if the second term is A plus D, then third term is A plus 2D, right? A plus 2D means, can I write it as A plus 3 minus 1 into D? Can I write this A plus D as A plus 2 minus 1 into D? And can I write this A plus 1 minus 1 into D? So what is common everywhere? Minus 1 is common. But what is changing? The first number is changing. So that comes from the subscript. So it will be, if it is 1, you will put 1 here. If it is 2, you will put 2 here. 3 means you will put 3 here. In a similar way, what do you think A n minus 1 will be? It will be A plus n minus 1 minus 1 into D. I'm talking about A n minus 1. Okay, so what should you do? You should take the subscript and put it here, n minus 1 minus 1 into D, right? Plus you have another D, right? From here, what can you conclude? A plus n minus 2 into D plus D, which will give you the answer as A plus n minus 1 into D, and this is going to be the value of an, which you have learned in the name of general term of an AP. Am I clear with this? This is what is called as the general term of arithmetic progression. Am I clear with this? Right? So let me know if it is clear. I'll give you time to copy later. If it is clear, I'll proceed to the next part. Okay, let me explain the theory first. Is it clear? Shall I proceed? Okay. So from this, if I talk about the general term of an AP, if I take the general term as Tn, right, what is the nth term going to be? It will be A plus n minus 1 into D, where A is going to be the first term and D is going to be the common difference. Simple. So A is the first term and D is the common difference. Then this is going to be the nth term. Clear with that? Now, the question is, what is the sum of these numbers put in AP? What is the series of this? Right? So if I take the sum of these n terms as A plus D plus A plus 2D plus so on, what will be the last term? A plus n minus 1 into D. My interest is to understand what this is. Does anyone know what is the value of this? Can you directly tell me? Sn is equal to n by 2 into. So 2a plus n minus 1 into d. You would have learned this last year, right, in your 10th grade. But the question is, how did you get it? So how did a mathematical expression of this sort came out? What is the logic behind it? A plus a. A plus an means you are adding only the first and the last term. Okay. Okay, then how did you get the 10 by 2? You see, this 2a is there, no? Split this 2a as a plus n minus 1 into d. A is the first term. That a plus n minus 1 into d is the last term. But that is okay. But how did you get this n by 2? That we need to understand, no? So for that, let's see. It's a simple derivation. Nothing so complicated. Can I write the same sum of n numbers as the reverse of it? 1 plus 2 plus 3 is the same as 3 plus 2 plus 1. Meaning, I will just reverse this pattern so that the first term here will become the last term and the last term there will become the first term. So what should be the first term here? A plus n minus 1 into d. So that is the first term. What will be the previous term to it? A plus n minus 2 into d. What would be the term preceding it? A plus n minus 3 into d. If I keep on writing like this, what will I get these terms as? I'll get a plus d and a. Am I clear with this? Okay. So if I add on both the sides, here I will get 2 times Sn. And what will I get this side? I'll add the first term to the first term. So a plus n minus 1 into d is 2 times a plus n minus 1 into d. So that is going to be the first term of 2 times Sn. Make sense? Plus second term plus second term. A plus a, 2a plus d plus n minus 2 into d. See, n minus 2 into d plus d is how much? nd minus 2d plus d, it is n minus 1 into d. So it's very simple. N minus 2 plus 1 is n minus 1. So a plus 2a plus n minus 1 into d. What about the third term? A plus 2d plus a plus n minus 3d. So a plus a is 2a plus n minus 3 plus 2. N minus 3 plus 2. N minus 1. So it is n minus 1 into d. So on. Add the last term to the last term. A plus a is 2a plus all you have is n minus 1 into d. So basically, when you do this, you are getting the sum of 2a plus n minus 1 into d n times. So this is n times 2a plus n minus 1 into d. But what is there on the left hand side? It is 2 times Sn. So Sn will be equal to n by 2 into 2a plus. That's the answer. So that is why you got that. Okay. This is one of the formulae, or n by 2 into, you can write this 2a as a plus n minus 1 into d. Okay. So this is going to be n by 2 into a plus an. Basically, it is the formula as n by 2 into first term plus last term. This also you would have used it, provided you know the first term and the last term of that sequence. Am I clear with this? So these two are going to be the formulae of sum of n terms that are there in AP. Is that clear? Right. So just make a quick note of it. Yeah. Sorry. See, it is important that you should know why it has come. In algebra, logic is more important. From exam point of view, this is not important. No, nobody will ask you math derivations. It's all applications. Done, no? Shall I proceed? I mean, to the next slide. So this is something you can just make a note of. What is the general term of an AP? A plus n minus 1 into D. Here. Hmm. Sum of n terms in AP. Bhaskar. Done? Done? 1 minute. Okay. We're done. Okay. Listen. So now we are ready to solve problems. So example number 1. Write the first 3 terms in each of the following sequences defined by the following. So a n is equal to 2n plus 5. So they want the first 3 numbers. So n should take the value of 1, 2 and 3. So if I put 1 here, what am I supposed to substitute here? 1. So 2 plus 5 is going to be 7. If I put 2 here, what am I supposed to substitute here? 2. So answer will come out as 9. So what will be the value of A3? So it is going to be 6 plus 5, which will be 11. So how are these numbers actually? What kind of a progression is this? 7, 9, 11, no? Basically an arithmetic progression. It's an arithmetic progression. Right? So in the second problem, if you observe, an is equal to n minus 3 divided by 4. So an is equal to n minus 3 divided by 4. If I take n as 1, a1 will be equal to 1 minus 3 by 4, which is minus 2 by 4 or minus half. Similarly, a2 will be equal to 2 minus 3 by 4, which is minus 1 by 4. A3 will be equal to how much? 3 minus 3 by 4, which will be 0. So a1 is minus half, a2 is minus 1 by 4, and a3 is 0. Okay, they asked only the first 3 terms, no? Yeah, the first 3 terms. Shall I proceed? Listen. So example number 2 is, what is the 20th term of the sequence defined by an is equal to n minus 1 into 2 minus n into 3 plus n? So what is the 20th term? So A20 is what is needed. So it is going to be 20 minus 1, which is 19, into 2 minus 20 is minus 18, into 3 plus n is 23. Right? When you multiply all these 3, you should get the answer. What is it going to come out as? Minus 7866. So on multiplying all these things, you will get the answer as minus 7886. right? See, multiplication and all, you do it later. We'll concentrate on the logic.
7866.
7866. I wrote 86. Okay, correction. So on multiplying all these terms, we get minus 7866. Right. Next. Example 3. Let the sequence A and be defined as follows, where A1 is equal to 1 and AN is equal to AN minus 1 plus 2. What are they saying? A1 is equal to 1 and AN is equal to AN minus 1 plus 2 for all values of n greater than or equal to 2. Meaning, the first term is 1 only. Whereas, after you start finding A2, what you need to do is put 2 here. So here A2 is equal to A. When I put n is equal to, what will I get here? I'll get A1 because 2 minus 1 is what is going to come out. So A1 plus 2. But A1 is already known from here. So you substitute it here, it will come out as 3. Similarly, if it is A3, A3 will be equal to A 3 minus 1. So it is A2 plus 2. So A2 you will take it from the previous step. It is going to be 5, right? So find the first 5 terms and write the corresponding series. Okay. A3 is this. Then what about A4? What about A4? A4 will be equal to A3 plus 2. A3 is 5. So 5 plus 2 will come out as 7. Then what about A5? So A5 is equal to A4 plus 2. A4 is 7. So 7 plus 2 will come out as 9. So what are the numbers? The sequence is going to be, the first 5 terms are going to be 1, 3, 5, 7, 9. They ask, write the corresponding series also. What is going to be the series? 1 plus 3 plus 5 plus 7 plus 9. So it is going to be 10 plus 10 plus 5. It is going to be 25. The sum of these numbers is going to come out as 25. Is the point clear? Right. Okay. So here actually they didn't when they told the corresponding series, no. Wait, correction here. So when you write the corresponding sequence, it will be 1, 3, 5, 7, 9. Right? Sorry. The first 5 terms, it is going to be 1, 3, 5, 7, 9. Okay, accepted. They're asking us to write the corresponding series. Corresponding series means 1 plus 3 plus 5 plus 7 plus 9 plus so on. They didn't ask us to write the series with the 5 terms. Corresponding series means it's an infinite series, which will be of this format. Is the point clear? So this will be the answer. Right? Shall I proceed? So let's start with exercise 8.1. An is equal to n into n plus 2. What is the question? What are they expecting us to do? So find the first 5 terms. Okay. So coming from the beginning. So question is first find the first 5 terms of this sequence. So what is going to be the value of A1? A1 will be 1 into 2, 1 into 1 plus 2, which will come out as 3. A2 will be equal to how much? 2 into 4, it will be 8. A3 will be how much? 3 into 5, which will be 15. A4 is how much? 4 into 6, which will be 24. So A5 is how much? A5 is 5 into 7, which is going to be 35. So the terms are going to be 3, 8, 15, 24, and 35. Okay. So I'll just go faster because these are all simple problems. Right. So first 5 terms of this general term, which can be derived from this general term. So what is the value of A1? A1 will be 1 divided by 1 plus 1, 2. What is the value of A2? 2 divided by 2 plus 1, which will be 3. What about A3? A3 will be 3 divided by 3 plus 1, which is 4. What about A4? A4 will be 4 divided by 4 plus 1, which is 5. And A5 will be equal to 5 divided by 5 plus 1, which is 6. So basically, number divided by n plus 1. Right? Next. An is equal to 2 power n. So A1 is equal to 2 power 1, which is 2. A2 is equal to 2 power 2, which is 4. A3 is equal to 2 power 3, which is going to be 8. A4 is equal to 2 power 4, which is going to be 16. And A5 is going to be 2 power 5, which is going to be 32. So this will be the sequence, or the first 5 terms of the sequence. Okay. Next. So what is A1? A1 is 2 minus 3 by 6. So it is minus 1 by 6. So A2 is equal to 4 minus 3 by 6. It is 1 by 6. So what is A3? A3 is 6 minus 3 by 6. It is 3 by 6, which is half. So what is A4? 8 minus 3 by 6. 5 by 6. So what about A5? 10 minus 3 by 6. 7 by 6. Right. So this is going to be the required sequence of the first 5 terms. Okay. Next. So what is the value of A1 here? Minus 1 power 0 into 5 power 1. So minus 1 power 0 is 1, 5 power 1 is 5. So what about A2? Minus 1 power 2 minus 1, which is minus 1 power 1 into 5 power 3. So 5 power 3 is 125, 125 into minus 1 is minus 125. Am I clear? So A3 is how much? A3 is minus 1 to the power of 3 minus 1, which is going to be 2 into 5 power 3 plus 1, which is 5 power 4. So it will be 5 power 4 itself. Okay, you can leave it as it is. 5 square, sorry. So 5 square here, it is 25. Correct. So first one is 5 square. So similarly, if you take A4, right, what is A4 going to be? A4 is going to be minus 1 power 3 into 5 power 5. So it is going to be minus 5 power 5. And what is going to be the value of A5? A5 is minus 1 to the power of 5 minus 1, which is 4, into 5 power 6. So it is going to be 5 power 6. That will be the answer. Okay. How many 14 problems are there, I guess? Yeah. So I think the remaining problems are of the same nature, no? Right? Can you guys do that? So leave some space for it. So I'll explain the next set of concepts. Okay. Shall I proceed? Now, we'll discuss about the next set, that is the geometric progression. Okay. So now we'll discuss about the next set, that is the geometric progression. So let's look at a set of numbers like this. See, if I think of a sequence like this, 2, 2 square, 2 cube, 2 power 4, so on. What is the pattern you're able to observe? You're able to observe that the subsequent number is getting multiplied with 2. right? So, or else what I can say is, if I take the ratio of the number to the preceding number, the value will come out as 2. Similarly, if I do 2 power 3 divided by the subsequent number 2 square, I'm going to get the answer as 2. So what happened in arithmetic progression is, you used to take the difference between the subsequent numbers. Here, what are you doing? You're actually taking the ratio. So you're taking the ratio of the number to the preceding number, right? And you're getting a common value, like how in the case of arithmetic progression, because you took difference, the number came out as common value, called it as common difference. Here, since you took the ratio, this is called as common ratio. It's called as common ratio. Is the point clear? Right? So what is basically happening? If you know what is the first term, if you want to write the second term, okay, if you know the first term and if you know the common ratio, how will you write the second term? So first term multiplied with the common ratio. How will you write the next term? This number multiplied with common ratio. How will you write the next term? This number multiplied with common ratio. So that is how the pattern keeps on going. Am I right? Now see, if I take the sequence to be A1, A2, A3, so on till AN. Okay. Then what is the definition of geometric progression telling me? That if you take the ratio of the subsequent number to the preceding number, you should get a common value, right? That is, if you do A2 by A1, you should get a common ratio. So common difference, we use D. Difference starts with D. Similarly, ratio starts with R. Okay, you call it as R. This implies A2 will be equal to A1 times R. Make sense? Now, A3 divided by A2 should be R. A3 divided by A2 should be R, which implies A3 is equal to A2 times R. But what is A2? A2 is already A1 times R. So you will write it as A1 R into R, which is going to give you A1 R square. Similarly, A4 divided by A3 is going to be R, which implies A4 is equal to A3 times R. So that's what we wrote it here, the preceding number multiplied with R, right? So this will be equal to A1 R square into R. Am I right? A3 is A1 R square. This R is there. So it is going to be A1 R cube. So like this, if I follow the pattern, then what is going to be the nth term in the geometric progression? An will be equal to A1 times R power, observe the pattern. If it is 1, if it is A1 is basically A1 into R power 0, because you don't write that R at all. So can I write this as A1 into R power 1 minus 1? So I can get 0 as 1 minus 1, 2 minus 2, anything. But there is a reason why I'm writing it as 1 minus 1. Similarly, if I wanted A2 is A1 times R. Can I write this as A1 times R power 2 minus 1? Similarly, here can I write it as A3 is equal to A1 into R power 3 minus 1. This one, A1 into R power 4 minus 1. That is A4. So whatever is the subscript here, then R should be raised to the power of subscript minus 1. So what will be the nth term? A1 to the power of, sorry, A1 into R to the power of n minus 1. And this is going to be the general term of geometric progression. Makes sense? Simple, right? So just make a quick note of. 1 minute. Okay. Shall I proceed to the next topic? So you wrote the general term in AP. Now we'll see the sum of n terms in GP. Okay. So now we'll find out what is the sum of n terms in GP. So what is it going to be? It is going to be A plus AR. So how is the sequence going to be? A, if you know the first term and if you know the common ratio, what will be the first term? A, second term will be AR, third is AR square, so on till AR power n minus 1. So A plus AR plus AR square plus AR cube plus so on till AR to the power of n minus 1. Right. So we are interested to calculate the sum of this sequence. What we will do is, unlike the case of arithmetic progression where we wrote it in reverse, it will not work here. So what we need to do is, we will multiply this Sn with R. So second step, what I'm going to do is, R times Sn is equal to how much? R times Sn is equal to, this A will get multiplied with R. So I'll start from here. It will be AR. See, instead of starting from here, I'm starting from here. It will be AR plus this AR. Basically, I hope you're able to understand. R is getting multiplied with A, it is AR. R is getting multiplied with AR, so it is AR square. Plus R is getting multiplied with AR square, AR cube. I hope this arrow marks help you, right? So next one will be AR power 4 plus what will I get here? I'll definitely have AR power n minus 1 because this would have got multiplied with this term. AR power n minus 2 would have got multiplied with R, it will be AR power n minus 1 plus AR power n minus 1 multiplied with R is AR to the power of n. Makes sense? AR to the power of n. Is there any doubt? See, basically, you will have the same number of terms. Only thing is, I shifted by 1 unit to the right. Instead of starting from here, I started from here. Did you understand? You have a confusion? Last term, you got it by multiplying with this. So what is the last term here? AR power n minus 1. AR power n minus 1 multiplied with R. You are clear now? Yeah. So what you are going to do is, you are going to subtract that. So when you are going to subtract, right, everything will have a minus sign. So what will happen? Sn, if you take it common, Sn into 1 minus R is equal to, A will come out, right? A is getting subtracted from nothing. AR and AR will get cancelled. AR square will get cancelled. AR cube. The process continues till AR power n minus 1 and AR power n minus 1. You will have minus AR to the power n. Did you understand or not? So what is left out? You have minus AR to the power n, and here you have A left out. Makes sense. Okay. So Sn into 1 minus R is equal to A into 1 minus R power n. So Sn will be equal to A into 1 minus R power n divided by 1 minus R. This is the formula. Or, listen to this carefully, or A into R power n minus 1 divided by R minus 1. They both are same. What I did is, I took the minus sign outside here and I took the minus sign from the denominator so that it will change like this. So what I'm trying to tell you here is, you use this formula when the value of r is less than 1. You use this formula when the value of r is greater than 1, because you're doing r minus 1. No, if it is greater than 1, you will get a positive value. If you're doing 1 minus r, if it is r is less than 1, you will get a positive value. Or else you think you don't want to confuse yourself, remember only one of the formulae and apply it. Okay. So generally what we do is, this can be applied when the value of r is less than 1, and this is applied when the value of r is greater than 1. If you think you don't want to confuse yourself, you can remember either of them and apply it for all the problems. Is the point clear? Yes. So this is the derivation for sum of n terms in GB. Shall I proceed? See, the next concept that we are going to discuss is called as arithmetic mean. Okay, it is not arithmetic progression, it is arithmetic mean. Okay, listen to this carefully. See, suppose I have two numbers A and B. Right? I have two numbers A and B. If I just give you two numbers, will you be able to decide what kind of a progression it is? I'll tell you, the numbers are 2 and 4. Can you tell me what progression it is? You cannot. So minimum number of terms that are required are 3, right? So what we are going to do is, as the name suggests, arithmetic mean. Arithmetic generally means addition. Okay, what do you mean by arithmetic mean here is, I need to introduce a number between this 2 and 4, which is A and B here. I need to introduce a number between A and B, so that when that number comes into picture, then you can say that this sequence is an arithmetic progression. So I need to choose a number between 2 and 4, so that when I introduce that number between the 2 and 4, the sequence should become a arithmetic progression. Okay. So let me say that the number I'm going to introduce is capital A. So arithmetic mean is represented by the symbol capital A. Did you understand what is arithmetic mean? I'll repeat it. Arithmetic mean is that number you're going to introduce between two numbers, so that the sequence becomes a arithmetic progression. Right? This is A. Yes. So A and B are the extreme numbers. Between the extreme numbers, you need to introduce one number. That number is arithmetic mean. After you introduce this number, what will happen to the sequence? The sequence will become arithmetic progression. So if it becomes arithmetic progression, what does the definition tell? The definition of arithmetic progression says the difference between the subsequent numbers is always a constant, meaning capital A minus A. See, this A is something that I have introduced. So A is still a variable. What are the two given numbers? A and B. A and B is okay. A and B is 2 and 4. But I don't know what number I'm supposed to put between 2 and 4, so that the sequence becomes arithmetic progression. Okay. So I'm saying that number is A, capital A. So capital A minus small a should be equal to B minus capital A. Now rearrange it. this A will come this side. So 2A is equal to A plus B, or capital A is equal to A plus B by 2. So this is telling me that if I have given you two numbers, you introduce a number which is the average of those numbers, so that the sequence becomes a arithmetic progression. Let's try to understand this. For example, I have 2 and 4. I need to introduce 3 in between so that this becomes an arithmetic progression. How did I get that 3? 2 plus 4 divided by 2. So I got it like that. Suppose I give you another sequence. Let's say I have given you 1 and 5. Introduce one number in between so that it becomes arithmetic progression. 3. So 1 plus 5 by 2. So 1, 3, 5. So 3 is what is called as the arithmetic mean. I hope it is clear. Is there any doubt? It can be. For example, you take 1 and 4. So what will be the number? 1 comma 5 by 2 comma 4. It can be 2.5. It can be anything. There is no condition on arithmetic mean. You can write anyway. Fraction is more convenient. Okay. Right. So did you understand this? Listen, this is what is arithmetic mean. But this is not the challenging part. Part is, between two numbers, I'm asking you to introduce n arithmetic means so that you convert the sequence into arithmetic progression. Are you able to understand? So we need to answer that question. You need to introduce how many? I introduce only one, A. Like that, I want to introduce n arithmetic means. Between whom? Between A and B, so that the whole sequence is going to appear like a, it's not appear, the whole sequence will become a arithmetic progression, right? I'll tell you how to do that. Before that, copy this. Am I clear till this point? Done. Shall we try that and see? No. Can I completely erase this? Right. So we have two numbers A and B, between which what is the task? Introduce n arithmetic means so that the sequence is arithmetic progression, right? So A is here, B is here. In between, A1, A2, A3, so on till AN comma B. So I've introduced n arithmetic means. So what I'm going to do is I'm going to understand what should be the common difference. Okay. I'm still sticking to the basic. What does AP tell me? That the difference between the subsequent numbers is same. Okay. So if A1 minus A, it is going to be the same as A2 minus A1 is going to be the same as A3 minus A2, so on till B minus AN, which I'll call it as common difference D. Okay. And the second logic that I'm going to use is, I'm going to write B in terms of A and D. I'm going to write B in terms of A and D because A is given in the problem. D we can find out using this. If I know these two, then I'll be able to solve the problem. Okay. For that, we need to understand which term is B actually. Which term is B? What is the number given to that term? Is it nth term, n minus 1th term? Which term is this? Is it nth term, n plus 1th term, n minus 1th term? It is n plus 1th term, but that is wrong. It is actually n plus 2th term because you already have n numbers here. You have one number here. So B will be makes sense. So what is the general form of arithmetic progression? B, okay, I'll write that formula. An is equal to what is the general term? An is equal to A plus n minus 1 into D. Now here B is there, no? B is which term? A n plus 2 is equal to A plus n plus 2 minus 1 into D. So in the place of n, I wrote n plus 2, right? So this will be equal to A plus n plus 1 into D, right? But what is this term actually? This is B. Did you all understand this logic? So this is the trickiest part of this derivation. So what is B? B is the n plus 2th term, right? So this is equal to this. So from this, if I rearrange and write it, what is going to be the common difference? D is equal to B minus A divided by n plus 1. So it is going to be B minus A divided by n plus 1. Okay. So this is going to be the common difference, which will help us to find out the values of A1, A2, A3, so on. So since I know the common difference, what is A1? A1 is equal to A plus D. A2 is equal to A plus 2D. So like this, if I keep on writing, what will A and B? It will be A plus ND. It is ND because see, if it is 1 here, 1 times D, 2 times D, 3 times D, n means n times D. Is it clear? Right? So what you're supposed to remember in this is, if these two terms A and B are given, for you to write these n terms in between, you need to remember the formula of common difference. So what does common difference say? It is B minus A divided by n plus 1. Okay. So write this common difference and then solve it. Okay. So like how we had arithmetic mean, we also have something called as geometric mean. Okay. Then we have the relation between these two. With that, the theory of this chapter is over. Then we need to only solve the problems of 8.2. Is it clear? So as I mentioned the previous class, right? Tomorrow I'm not there. So you will have an online class tomorrow. Right? 8.2 will be solved by others, sir. So please cooperate with him. Okay, you have any doubt, just ask him. Make sure if you're practicing, if any problem is done after the class, you're practicing, you have any doubt, reach out on the student support. Is that point clear? Yes. I hope it's clear till this step. Right. Shall we wind up with this? Those are online. Am I clear?
Yes, sir.
Okay. We'll wind up.
Thank you, sir. Thank you, sir.